Okay, we're going to go through the Chapter 18 review. First of all, if you have a formula sheet, a couple of the formulas that you're uh, going to want that the mean of p hat is p, the standard deviation of p hat is the square root of p times 1 minus p over n. You're going to use those in these first couple problems. For the problems 3 and 4, that the mean of x bar is mu and the standard deviation of x bar is standard deviation divided by the square root of n. Make sure you have those readily available. Okay, so number one, it's believed 13% of people are left-handed. So these, you have a proportion, 13%, we're going to turn it to 0.13. The mean, according to the central limit theorem, is always the mean. So the mean would be 0.13. That's the center of the distribution. The standard deviation, you have to get your calculator. You just type it simply in your calculator, but you should show the work. You do the square root. I'm not going to do every one of these, but I want to show you. 1 square root of 0.1 times 0.87. You got to figure out the 0.87 divided by 10. I think the sample size is 10. We get 0.106. That's our standard deviation. That's the spread. Now the shape, you have to do the nearly normal condition. You have to take 10 times 0.13, that's 1.3, that's less than 10. We already know it's not normal, but you have to do both. 10 times 0.87 is 8.7, that's less than 10. So therefore it's skewed right. How do I know it's skewed right? 13% is more on the left side. You'd have more room to go to the right this way than you do to the left. So it's going to be skewed right. Now, I make the test just like this. That it will be 3 points on the test that you should be able to get. You talk about shape, center, spread. You have to, the most work is for that one. Part B, it always is a follow-up with a bigger sample size. The mean is always the mean. So the mean, again, is 0.13. The standard deviation, you take the square root of, now it's the same thing. This time we got a bigger sample size. We turned it into 100. Sample size, or standard deviation, gets smaller with a larger sample size. So 0.033. Now, depending on where, it could be 336. That's going to affect your answer a little bit in the normal CDF part of it. And I adjust for that. If you round it a little bit too aggressively, if you want to make that 034, that's fine. 0336, 033, I'd accept all of them. But now, you have to check nearly normal. 100 times 0.13 is 13. That's greater than 10. 100 times 0.87 is 87. That's greater than 10. So it is nearly normal, which then brings us to this question, which we can flow into. Because it's nearly normal, we can draw a normal curve down here. And our mean is the 13 that we're bringing from part B. But this problem, I usually have one like this on the test, so pay attention to this one. Pay attention to the other reviews that do this. In a sample of 100, what's the probability we find over 15 people are left-handed? Now that's 15, that's a count. You need to divide that into your sample and turn it into a proportion. So you don't just put the 15. 15 would be way out here, okay? 0.15 is what we're looking at because you have to divide that 15 by the 100 to get that. So now we do a normal CDF. Now if you do the z-score, all that's great. I will accept norm CDF with 0.15 being your lower bound, 999 being your upper bound. I'll do it the calculator way here. So menu 652, 0.15 is our lower boundary, 999, we're shading the upper tail of the curve. We're shading from here on up, so that's where we're shading. Our mean is 0.13 and our standard deviation 0.0336. I'll use the little less rounded value. We get 27.58. So if you do not label lower bound, upper bound, mean, and standard deviation, you have to then do the z-score. This is consistent on the AP exam. This actually is what we call calculator speak. Not every calculator has a norm CDF function. It might have a different name for it. So that's technically not statistics. You have to do the z-score, but this has been allowed on the AP exam as long as students do this labeling. If they don't label it, they will not get credit for their z-score work. Then we get 27% chance, 28 if you round it, that over 15 lefties. Make sure you have the answer and the context. All these, when you do the z-score, are 4 points. Okay, so number 2, same thing. The mean is 97%. We're going to convert it to a decimal. So the mean is 0.97. The standard deviation, square root of 0.97 times 0.03 over 100, we get 0.017 for the standard deviation. We have shape and spread. Now, if you take 100 times 0.97, you get 97. That 97 is greater than 10. But 100 times 0.03 is only 3 expected failures, and that's less than 10. It has to be both. You have to check both. We check this one works. We get enough successes, not enough failures. Since 97 is clear over here, if you graph it, 97 has more room to move to the left, so this distribution is skewed left. Then we take a bigger sample size. Square root of 0.97 times 0.03 divided by 800. It results in a smaller standard deviation, 0.006. Our mean is still 97. That's the center. Our standard deviation, show the work, 0.006. 800, we'll do the work on that. 800 times 0.97 is enough successes. 800 times 0.03 is enough failures. Both are bigger than 10, so it's nearly normal. That's good. We can go to the curve. 97 is the middle of our curve. But over 4% are late. Now, this one, think about this. 4% of people being late would be the same as 96% being on time, but we got to figure out, well, where do we end up with over 4%? So think of a number over 4%. 5% being late. If 5% are late, we'd end up being down here at 95 on time. So therefore, we're going to shade the lower part of the curve because that's the equivalent. Under 96% is the equivalent of over 4%. So we just make it simple. We do our norm CDF from negative 999. We stop at 96. 97.97 is the mean. The standard deviation comes from up here. And we get 4.7% chance. I'll do that quick on here. We'll go menu 652, negative 999 to 0.96, 0.97, 0.006. We end up getting 4.7% of the curve. If you have to, multiply by 100 or you round it to 4.8, good enough. We don't get too picky on most of the rounding. But now this next one, we have to use the mean formulas. The mean of x bar is the mean. The standard deviation of x bar is the standard deviation divided by the square root of n. So make sure you change formulas. Now with means, the sample needs to either come from a normal distribution or it needs to be at least 25. So here, the weight of an adult male in the U.S. is 172. Okay, so what do we expect the mean to be? The mean is 172. Center. The standard deviation is 29 divided by the square root of 4. So we'll do it. 29 divided by square root of 4 is 29 over 2. Make it a decimal. 14.5. If you put 29 over 2, I'd count it. But the sample is 4. 4 is a small sample size. Really should say 4 is less than 25. It's not enough to normalize. Now we should read. Up here, it doesn't say if the distribution is normal. It doesn't say if it's skewed left, skewed right. So our distribution would be unknown. It would be like the parent, but we don't know what it was like. Now every year I put a question on there. You have to be aware. If this distribution said it was skewed right, this would be not just like the parent. You would say it's skewed right. It is like the parent, since the parent is skewed right. If it says skewed left, it's skewed left. If it says it's normal, it's normal. But B, we take a bigger sample size. We go to a sample of 27. Well, the mean is still the mean, so the mean is always 172. The standard deviation is 29 divided by the square root of 27. So 5.58 is our new spread or standard deviation. Since we're now averaging 27 numbers, that's greater than or equal to 25, so it is nearly normal. Okay, what's the chance in this distribution? We always take part B, we bring it down to part C because we found out it's normal, we can use it. What's the chance that we average over 180? We draw a curve. I get students every time, they don't draw the curve. If you don't draw this curve, you got -1. Don't get -1. Normal CDF from 180 to 999. Label it, lower bound, upper bound, mean 172, standard deviation 5.58. We should get a 7.6% chance that we end up over 180. I'll do it real quick. Then use 652, 180, 99999, 172, 5.58. 7.5, 7.6% rounded. All right, number 4. The mean is supposed to be 170, so this is another one on means. The mean is 170. Okay, the standard deviation is 15, but we got to divide by the sample size, square root of 9. 15 over the square root of 9, should be able to do it in your head. Square root of 9 is 3, 15 divided by 3 is 5. Shape, or center and spread, now shape. Now it says that the known population is nearly normal, so this one, the shape is nearly normal because the parent is normal. Like I said, if we said this one was skewed right, it'd be skewed right because the sample's too small, it's only 9. Okay, but B, we get a bigger sample size. We sample 52 acres. Well, the mean is still 170. The mean is always the same. The standard deviation is going to shrink a little bit. Okay, we got a sample of 52 this time, so it shrinks to 2.08. 52 is bigger than 25, it's nearly normal. You could also say because the parent's normal, it's normal. But now we take this information from B, we apply it to C. 167, we draw a curve, we shade. Don't forget the curve and get -1. I'm not going to do this one on the calculator. You should come up with normal CDF. Make sure you label your normal CDF or do the Z-score. You should get 7.5% chance you're under 167. All right, number 5. We want to estimate the proportion of students that are taking AP classes in schools in the nation. We randomly sample 705 students and find 255 out of the 705 are taking AP classes. That's 0.36, 36%. Okay? What is the standard error? Now, the standard error is simply where you take the square root of the p hat you got, and I'm just going to take it at 36, times the q hat, and you put it over the sample size. Our standard error is 0.018. Create a 95% confidence interval. But now, 5B is worth 6 points. I ask this one on the exam every year, and I have students who miss the first 3. If you're asked to do a confidence interval, if you went through the worksheet, if you didn't go through the worksheet video, go through that. You need to say random independent. That's 2 points. It's the cheapest points you're going to get. We have 255 successes. We subtract from 705. We get 450 failures. That's greater than or equal to 10. So it's nearly normal. Make sure you say nearly normal. Now you have the third assumption done. You say one prop Z interval. Now, whatever calculator you're using, menu 665 on the TI Inspire is very easy. We had 255 as our successes. If you're using an 84 or some other TI calculator, it's still pretty similar. Okay, and we want 95%, so it defaults to 95. Now, whether you use 95 or 0.95, it still works. But you come up with the 2 values. Now you have to know the sentence. Make sure you say one prop Z interval. Again, if you try writing this formula that I have here is wrong because it didn't include the hats. If you do something as simple as not put the hats on, it gets counted wrong on the AP exam. So I would recommend on the open response portion, you simply name it. You should know how to use these formulas for the multiple choice. That's where it's going to help the most. But the sentence, I am 95% confident the true proportion of AP taking students is between 0.326 and 0.397. Get it right off the calculator. If you're trying to build these by hand, I'm going to guarantee you're going to make mistakes. Don't do that. I hope you watch these videos. Now, what does 95% confident mean? 95% of such intervals have the true proportion. That's all it means. Okay, number 6. We want to estimate there's 80 students at a small high school. We sampled 20 of them. Here's the problem. Can we create a 90% confidence interval? The answer is no. If you sample 20 out of the 80, you're sampling 25% of the population. You're sampling over 10%, you're going to affect independence. Now, I may or may not ask this on the test, but you can't sample over 10% of the population. What's the standard error? Now, in the sample, we found 10 watched the show. 10 out of 20 is 0.5. You take the square root of 0.5 times 0.5 over the sample size of 20. You're going to get 0.11. Still the same way to find the standard error. All right, number 7. If a question says assume all conditions are met, you do not have to do the random check, independent check, nearly normal check, but you still have the other 3 points. So you would do 1 prop z interval. Now again, if you are not doing this in the calculator, if you're not doing menu 665 or on the 84 going to find the 1 prop z interval, do it. We have 58 successes out of 352. We do a 95% confidence interval. We get 0.126 to 0.203. Say 1 prop z interval, that's a point, that's your work. I am 95% confident the true proportion of guitar players is from 0.126 to 0.204. Go back in, same data, change it. Menu 665. .58 out of 352, and we're doing 90% confidence. It changes the interval. 1 prop z interval, I'm 90% confident the true proportion of guitar players is from 0.132 to 197. Which one's bigger? 95% is wider. The reason it would use a bigger z-star. Think about, you're going more standard deviations away. I would accept if I ask that question, it's because I used a bigger z-star. It's counterintuitive. The wider you go, the more confident you are, the wider the interval. You look less accurate with a wider confidence. All right, according to the searches, now we're using these numbers, could it be 20%? No, 20% is not in the interval. 0.2 is not there, so I don't think it is that. All right, number 8 and number 9, you got to be able to solve these questions. If you can't come up with these, you got to work on your math. This is simple algebra. I'm not going to go through the algebra. Make sure you check those. I'm going to end there for today. Make sure you get this one comes out 474 point something. This one I think is 138 point something. Whatever the something is, you always go up. And the reason you go up, you won't be within that margin of error. Any partial person is a person when you're determining how many you should sample. I hope you watch this video. Do well on the test.